Today's guest is Jordan Kyriakidis, who is the founder and CEO of QRA Corp, a company based in Nova Scotia, Canada, Halifax. And we're going to talk about what their company does, what it offers to the systems engineering industry and also to their individual customers, and learn quite a lot about Jordan's background that led to him to create this company. So welcome, Jordan.
Thank you, Joshua. It's a pleasure to be here.
Right. Jordan, could you give us a bit of an overview of your company, QRA, and what does the acronym stand for?
Sure. The acronym doesn't stand for anything. It's just the initials. The Q stands for quantum, as a nod to my background, which I assume we'll get into. What we actually do right now, we are a technology software company, and we sell primarily to enterprise and to engineering organizations. And we solve three problems for our customers, and they're all centered about requirements and improving requirements. One problem that we help solve is a lot of our customers, they undergo difficult requirement reviews, very costly, very timely, and the outcomes aren't as well as they want them to be. Second problem is that really some of our customers lack an understanding of what are requirements best practices, right? They know that the requirements need to be improved, but they don't have a good understanding of what are the best practices and how to verify that you are adhering to those best practices. And the third problem is just a general improvement of requirements quality, especially if requirements are going to go on. Typically they are the initial phase of a product development or systems development, and they know that poor requirements quality will have compounding dangers further on in the life cycle of the development process. And so they really want to improve quality. Almost all requirements today are written in natural language. In fact, most of the world's information is written in text. So natural language processing and natural language understanding are the appropriate technology to use here. So what we actually do with our software tools is provide a quality score for each requirement that you have, and also for the collection of requirements as well. We would look for term consistency. So if you call something, a rover, a module, a vehicle, the same thing, different terms in your document, we'll flag those and say maybe you should, consolidate the terms. Check for units consistency. We can look for requirements that are very similar, which often means they contradict each other. So those types of solutions we provide to our customers.
Okay. So when QRA company is turning up to a company or a project, what would it look like from day one? Are you consuming requirements that already exist in Word documents or other requirement management tools?
Yeah, so it is a product that they would buy and install on their premises. And if they have requirements written, we have several integrations, Word and Excel. So many, even for large projects, start off in either Word or Excel. And so we provide an integration to that so that you don't have to move your requirements anywhere else. You can analyze them wherever you are. Also, many of our customers use specialized requirement management tools like Doors, which is a product by IBM. There's Polarian, which is a product by Siemens. There is JAMA Connect by JAMA, right? So if you use those, our QV Scribe is the name of our product. It integrates directly with these tools, and you don't have to move your requirements anywhere. You can just stay in place. We provide this added functionality on top. It's kind of a semantic layer on top that'll just analyze your requirements. So you can analyze requirements that exist, but also if you're authoring requirements, our product is right there beside you, advising you as you type the requirements on the quality of them.
So is it kind of almost like you're adding like this layer of a skilled requirements engineer who is analyzing either requirements that you're generating or existing ones, and then within whatever existing database you already have, and as you mentioned, improving their quality or guiding engineers to be able to improve their quality?
That's right. In fact, a lot of our customers have, the reason they want to improve requirements quality, for example, is that they may have a lot of engineers writing requirements that are very young, and so don't have the experience, or English is not their first language. And so typically they would be paired with a senior engineer, and there is a lot of back and forth on improving the quality of the requirements. They may not be atomic. They may have excessive continuances. And so, the senior engineer would advise them and tell them to break it up. And the issue they have if they don't use our tool is oftentimes they'll go into a review meeting and they end up talking about the syntax of the requirements as opposed to whether the requirement is correct, right? So using our tool allows them to have the discussion at a higher level, right? Where they're talking about, is this the right thing that we want to build? Does this actually capture our intent? Instead of, no, what do you mean by this requirement? Or this seems to contradict that requirement. So it's a higher level of discussion they can have.
And are you finding that the demand for this type of product or service is on the rise? That people talk about how systems are getting ever more complex, and it sounds like that would only mean that you would need these types of tools even more.
Absolutely, yeah. The demand is increasing a tremendous amount, and we can get into why that's increasing, but that is absolutely true. In fact, the first product we built was design tool to make sure that the designs were correct, right? And what ended up happening is most of our customers ended up comparing their design implementation with the requirements. And what we found out is most of the requirements are very poorly written, right? And everyone agreed that they're poorly written. And so, I'm a physicist by background, so by nature, I like to get down to first principles. In this case, it's finding the error as early as possible. And we realized fairly early on that actually you can make mistakes even before you get to the design process when you're first capturing your intent and writing down the requirements. So we should focus there, right? And that's where we saw a great success, both in commercially as a company, but also the value we provide and the solution provide to our customers.
Okay, yeah. So, I mean, how did the company come to be created? I knew you were a professor at Dalhousie University in quantum physics, and so, as you mentioned, into requirements or tools to improve requirements seems like a big leap.
It is. So I am a bit of an accidental entrepreneur. The plan wasn't to do what we're doing; it's just following my nose and following the interesting problems. Right? Like as you said, I am an academic by training, and an academic running a company. I would say there's pros and cons associated with that. But my background is in theoretical physics, and quantum theory in particular, quantum computing, quantum dissipation. That was kind of my bread and butter. And, I was, for many years, I was on 14 years or so, I was on the path to being the venerable theorist with the leather elbow patches and the whole bit. But then I ended up getting a R&D contract on quantum computing with an aerospace company. And that contract was very successful. The value of the contract ended up increasing. The team expanded to service the contract, but it became progressively more applied. So we went from doing the fundamental science, and then, from there I progressed to understanding the engineering problem they were trying to solve. And so it became a bit more applied. And then from there, I went and I learned the business problem that they were trying to solve, and it became even more applied. And as we learned more about the problem, the way we solved it was kind of veered. The technology we used, the types, and the way we solved the problem changed as we went along. And we ended up at a point where I thought, okay, I've kind of deviated quite a bit from physics. The problem is very interesting, and these systems, these engineer systems, are becoming so complex. A lot of the principles that we have in theoretical physics we developed over the last half century, 1 century, can be applied now to these synthetic systems because they're so complicated, so many interacting pieces. And so we started making progress with that. It got to a point where I had to stop developing algorithms and start developing a product in order to get the engineers to actually use the algorithm to validate them. And then we had to get a company to distribute the product to get to the people. Right? That's kind of how it started. So the first, it kind of started backwards, I would say, than what is typical. And then after we did that, then we started learning about how to run a company, what that actually means. And now that was quite a year ago. That was quite a while ago, I should say. That's kind of our genesis of where we are today.
And when was the company founded?
Company was founded in 2013, late 2012, around there. So we've been around for a while. We've had various different iterations. We had multiple products, and we went through several phases. We started off as doing mainly large contracts, and a lot of services. But now we are primarily a product company. We just sell our product, and that's how we operate now.
Great. Yeah, it'd be great when you hit that 10-year anniversary next year.
Yeah, we are. The social committee is planning the party already.
Good. So you mentioned that you'd sort of worked backwards, and you were almost developing a product to solve your own problem when you were running your physics project. I mean, how do you see, which perhaps gives you an image of a lot of the systems engineering lifecycle, but how do you see the current state of systems engineering in general? Because I imagine through all of your customer interactions, you have quite a good view of that.
Yeah, and the fact that I am not a systems engineering by training, so I have a view from the outside, but I have a technical background, so I can understand it. That sort of gives me a different viewpoint on it. And so to my mind, the current state of systems engineering is that the fundamentals are quite strong, right? The principles on which they're founded are exactly the right principles. The systems engineering as a distinct discipline is gaining in importance all the time and will continue to do so for decades into the future. There's no question of that. At the same time, there is a great deal of change and evolution, even disruption coming. One of them is I think it's kind of three items in particular. One is technology. So new tools are available now that can automate parts of the work, especially design, right? We had a big, CAD, for example, is a huge change in the way the discipline works. Now, the tools and technology that's present today is, I think we're near another kind of inflection point. Another one is market demands. Products themselves are becoming far more complex. And so too are the methods and techniques of design and manufacturing, right? So even though your product may be simple, the way you manufacture is becoming increasingly more complex. And software is eating the world, right? Software is becoming far more important. And the third one is people, right? The experienced engineers are retiring and young ones are moving in. So there's kind of a generational shift happening now as well. So because of all these things, I would say there's a mix of anxiety and confidence, right? Anxiety because there is a change coming. It's not quite clear what the other side will look like. But there's also confidence because systems engineering is gaining an obvious and recognized importance, right? Appropriately so.
Mm-hmm. Yeah, and I feel almost like this current pandemic has, to a lot of governments around the world, the idea of sort of thinking about their country as a system or the globe as a system, and how not necessarily sort of engineering of it, but how things do interact with each other, and how ideas of resilience and these sort of various quality attributes that we might have in our papers that people say they care about, but then don't actively act on. I feel like that might have been sort of hopefully expedited some of the ideas that in systems engineering we have written a lot about in books, but maybe haven't been able to sell to the wider public.
I think there's no question of that, right? And in fact, that's something that resonates with me a lot because my background in physics in particular is theoretical condensed matter physics. And that's all about interactions of strongly interacting systems. And there, the whole name of the game, like in systems engineering, is it's really everything is in the interactions, less so about the components themselves, right? So we have this concept in physics as they do in engineering. Each component could be exactly a spec, could be working properly, but depending on how they interact, the whole system can have new emergent properties that do not live in an individual component. It's the interaction that matters. So you need to elevate the interactions to first-class citizens, and that gives you a new viewpoint on how the system operates. Right?
Mm-hmm. Yeah, it is very fascinating. And I kind of wanted to switch gears into your background as a quantum physicist. So I'm not sure how many people on the podcast sort of know about the potential of like quantum computers and how that might sort of impact how we do systems engineering design or other aspects of systems engineering. As an expert in quantum, like where are you seeing that impacting how we can do systems engineering?
I think quantum computing in particular, I would say the jury is still out. And what I mean by that, not whether it's going to affect it or not. I think it clearly is. The time frame of when it actually will affect it is not clear, but the technology clearly has the potential to be a game changer. What I mean that is unclear is how in particular it's going to be used, right? So one of the analogies I like to use here is if you think about the laser is just light, right? So, but when the laser was first invented, and think of the applications, we don't use lasers for light bulbs, even though it's just light. We don't use it for illumination. We use it for so many other different applications that come from lasers, even though it's just light. I think quantum computing is going to be a lot like that, right? It may be used in the design, but it's going to be used a lot, for example, in sensors for sure, in some processing and some AI systems, especially training of models could be used quantum computing. Cryptography, obviously, and security is obviously going to be a big deal. So it's going to be somewhere in there where these systems are going to play.
So we should maybe, as you mentioned, like a laser, we treat it as we've got this new component, and once that component is in the state where it can be commercialized, we might a whole load of applications that we don't even know about yet.
That's right. That's right. Yeah.
I don't know with like CDs. I don't know at what point from laser invention they were conceived, or
that's right.
if it was prior. Yeah.
That's right. So my own view, and this is speculation. My own view is that a quantum computer is not going to be a computer like we have now that you type on. It's just going to be a special kind of processor, right? I mean, that might happen. To me, I think that's unlikely. It'll be maybe more specialized processors that live in different places.
Mm-hmm. So I guess with your company today, you mentioned natural language processing and sort of AI. Would those be the most interesting new technologies that you would be actively engaging for your products?
Yeah, today we are a lot of AI and a lot of natural language processing and natural language understanding, only because that is where the requirements live, right? It lives in text. If you want to analyze them, you need to use natural language understanding, right? You can then go beyond that. You can think of what happens afterwards, like from, can we generate architecture diagrams, SysML diagrams from the requirements directly? Those systems can help that. Or if you have set of requirements and have a model, you can use AI to tell you what parts of the model are suspect that you may want to look at. Right? So there's those elements of AI as well. We don't do much of that right now. Right now, it's primarily natural language processing because that's where we are. And the technology in that is increasing so fast. I think Microsoft, using GPT-3, has just developed some tools where they can go from text to code. Right? It's been a dream for a long time to be able to do that. I think we're getting much closer now than we were before.
Okay. So I guess you can piggyback on the advances from what's going on with companies like Microsoft and Google, who seem to be really pushing the envelope in those algorithms.
Yes, to a certain extent, to a large extent, we can. We don't need to reinvent the wheels. The difference is if you look at engineering requirements or just technical specifications more generally, let's say, they tend to have a very particular kind of language where most of the general models produced by the big companies are trained on like newspapers, Wikipedia. They're just general prose, right? And so it's a good base, but we need to do some training on top of that to steer it towards the technical language. Right?
And if I find at least a lot of companies and organizations, they've almost got their own language that they have sort of, it's never been sort of codified or taught, but it's become that certain words mean certain things in certain
Yeah.
organizations, and they mean different things in different organizations.
They do. Yeah, that's right. So some of them have, like there's a difference between the word must and the word shall, right? They mean different things, and they codify them. So that's one of the example. That's a good example that we can help with. So they're codified. Most companies today verify that manually, right? Meaning they have typically a senior engineer who's one of the most expensive resources. Their job is to read the requirements with a highlighter in hand and circle all the errors they see until their eyes bleed. And so a lot of this stuff can be automated, right?
So with your sort of research and development, are you working with universities, or can you do all this in-house? Or
we do most of it. We do most of it in-house. Well, we do most of it. The product development is all done in-house. We work a lot with our customers. We do work less so now with universities than we did in the past, although we do have some university projects. These are mainly far-reaching things. Really, where we get the most insight, to be honest, is working with our customers, because we're a small shop and we have competitors, and our competitors are big companies, we can offer a much more insightful and specific solutions to them. And for that to work, we need to really understand our customers very well. And so we're oftentimes talking with our customers and developing with our customers to figure out what actual problems they have. And that's probably the source of our most insight comes from our customers.
Mm-hmm. That sounds very sensible, and seems like it's worked very well given you're coming up 10 years.
So far, so good. Yeah.
So are you working with customers of a wide range of industries?
Yes. Primarily, it's oil and energy companies. Medical device companies are probably our two biggest industries. Aerospace and defense companies are up there, and automotive and semiconductors are kind of sort of our industries, right? As you may not be so surprising, those are the industries that really value systems engineering. They have products that need to adhere to some regulatory standards, and there is a criticality associated with them. Like, it's important for them to be correct, and it's expensive to develop and expensive to change once they find errors down the line.
And
as opposed to say, I was just going to say, as opposed to say a typical software startup that if they find an error, they can just fix it, and no one dies if it goes wrong. Right?
Yes, it's like quite a different culture from. I don't want to say Silicon Valley, because I think that's a bit unfair, because in Silicon Valley you do have the Intels and you companies who do care a lot about zero failures, but it is maybe a little troubling that there was, perhaps since the year 2000 or so, when the big internet bubble, where there was a more focus on speed of execution as opposed to avoiding failure. And
that's right. Yeah, that's very true, and it depends a lot on the company, right? So you can think of, very crudely speaking, two groups of technology companies. One that came from pure software and are evolving into hardware. It's sort of one culture, let's say. It's a bit unfair, like you said, to categorize it that way. The other one is from mechanical and electromechanical systems, and like electrical engineering and mechanical engineering, that are now becoming more software. Eventually, everyone's becoming a software company, but depending on where they came from, they have different levels of rigor and tolerance to error in their work.
Yes. And do you find, but within the domains you do work, that there are differences in the cultures or the types of solutions that they prefer?
Not so much, actually. So it's not that we have to specialize to one industry or the other. In the end, they are all systems engineers, and there is a core set of principles they have to adhere to make these complicated systems at work. It is a combination of software and hardware, and there are a lot of interacting components, and there's a supply chain, and there's and different people working on it. So because of those things are the same, the technical issues are the same, and the solutions are the same. Where there are differences is more on the business side. So a company in the medical devices, for example, their main drivers may be time to market. So they want to make sure that the requirements are correct because it's a race to get something to market because their competitors are on their heels. And generally they'll have a product that they release and then they're working on the next one. Whereas someone, say, in aerospace, their main driver is correctness. Things have to be correct, and they'll take the time to make sure that it's correct. So the requirements have to be correct because they cannot tolerate any errors, right? So it's more the business drivers and the structure of the company, whether it's a set of independent teams or whether it's a more top-down structure. We find those differences among the customers, not so much the core technical issues.
Okay, that's interesting. And do you do work with clients outside of North America?
We do. We have some we do. We have some in Germany. We have some in India. I believe some in the UK as well. Most are in the States, and a lot of them are, though, multinational companies. So oftentimes we're on call where people from different countries are on the call.
Okay. And are you processing requirements in different languages outside of English?
No, now it's primarily English. We did get asked recently if we can offer a translation to Korean. We are not equipped to do that now. Luckily, most of the requirements are written in English. And the issue with doing things in different languages is a lot of the language models and a lot of the NLP and AI that we use are trained on English language, right? And so it's not a matter of just localizing the software, like the menu items and stuff like that. It's the core algorithm that are language dependent, right? And so right now we have more than enough work in English, but doing things in a different language isn't our future.
And I imagine jumping straight to Korean is maybe, they talk about languages similarity and I don't know, maybe English to French or English to German or something step by step.
Yeah, I would say probably the next, that's true. The next language to do, Germany or German would probably be the most likely, maybe French. It depends how big automotive, how big a sector automotive is going to be for us.
Yeah. So I guess if you're coming up on your 10-year anniversary for the company, where do you see the next 10 years for your company, but also systems engineering as an industry?
If I look at systems, so I think it's again, this is largely speculation. And if we look at, for example, so there's two ways I can answer. So one is, what is the state of requirements writing? How's that going to change over the next decade? And then there's a broader issue of, what systems engineering going to look like in general. So maybe if I talk about requirements first, and then we can veer off towards systems engineering a bit more broader. We talked earlier about the state of systems engineering today, and a lot of over the next the challenges facing requirements engineering today in the near future really are outcomes of those. One thing that we see different now is that most companies have either moved or are moving or plan to move from the traditional waterfall manufacturing technique into a more agile and flexible approach. Right? And so requirements are still vitally important because you do need to capture your intent of what you want to build. But whereas maybe in the past, requirements were more in principle one and done, like it's a very distinct phase. When you're done, you move on to implementation. What we're seeing now and continue to see is requirements like the design and the interfaces, the functional and physical components, all this information will in parallel mature over time, right? So there'll be several passes. And so that means that it's more important that as this information matures, you can maintain coherency and coupling between all these different artifacts, the design, the requirements, the interfaces. Today, this is done largely manual, and the burden is becoming just too great for individuals to do that. It's not really a question of the caliber of engineering. It's more a question of complexity and putting all that information into one head. I would say that's one big thing that both tools and processes are moving towards. It's going to take about a decade before that process is complete. And the other one is technology itself, right? And requirements are becoming more important now because, for a long time, this is still true today, but for a long time, most new products were incremental improvements over the previous versions. And so if you want to improve the process, they were incremental improvements. So the engineers that were building the products, they were pretty smart. If they saw the requirements were bad, and they were bad, the engineer could say, I don't know what kid wrote these, but I know what I'm doing because I built these products before and I know how to build it correctly. And they were largely correct. What's happening today, because there's new technology, sometimes disruptive technology, they're being introduced deeper into the products, mainly sophisticated software, like sensors into the controllers, into the actuators, are all becoming software enabled. And so engineers have less experience with these new non-incremental kind of systems. And so because they don't have the experience, they rely more on the specs and on the requirements. So even though the requirements, I would say were never really all that great, their importance is becoming greater as time goes on because people are relying on them more, and that trend is gonna continue in the future. And so things like the quality, the completeness, and the correctness of requirements are gaining a new importance now, because they're relied upon now more than ever.
Yes, and I think you touched on the retirement of engineers. So even if we weren't radically changing the various technologies in it, people will retire, and if you've lost that experienced person who was catching a lot of your problems, how long can you last? You can't keep on working forever.
That's right. That's right. So there are multiple issues coming in here for the human resources and the personnel problem, as well as the technological problem, right? And I think it's also true for systems engineering in general. But I think over the next, say, 10 years or so, there's going to be lots of changes on systems engineering itself. I think there are, the way you mentioned quantum computing, that's going to have an impact. But I kind of see three main technologies that really are just starting now. They're going to continue to spread. One is the whole idea of adaptive algorithms, that we're going to have algorithms in our systems that the algorithm itself changes as the more you operate the piece of equipment or the vehicle. Another one is generative design. And the third one is additive manufacturing. Right? So these three manufacturing technologies are going to just become more and more automated. And generally speaking, I think the whole idea of manufacturing, even a lot of coding as well, will become automated and commoditized. And so the value of the human, the systems engineer, is going to be even more so on the earlier stage of systems development, right? Early on the design, on the requirements, on capturing the intent, right? Not so much on the actual manufacturing itself. One important, and this is already happening now, NVIDIA has recently become the largest semiconductor manufacturer in the world, but they are a fabless semiconductor, right? And over time, they were able to grow at 3 times Moore's law, right? And the reason they were able to grow so fast and leapfrog over the competition is because of the weight they put on simulations, emulations, and design up front, right? Now that's going to happen. It's going to be just table stakes. So what happens in the early phases of project is going to become more and more critical.
Oh, wow. I didn't know that about NVIDIA. So where their competition was using physical prototyping, that NVIDIA was eliminating much of that into software simulation.
That's right. Yeah. So and design. And so when they were getting wafers back that far fewer errors than the competitors did, it still took 18 months, which is a general, Moore's law that remarkably lasted for so long. So that time scale is pretty much set. It's just set by the design, the manufacturing, the testing. It's just 18 months. But because they were so sure that the error rate was going to be so low, they had 3 teams staggered 6 months from each other, that when team 1 finished their 18-month cycle, when they were third into it, the second team would start, right? So they can release a new chip every 6 months by having 3 teams on 18-month cycles, right? They were only able to do that because they were so certain of their design. Right?
Wow.
And now I think that level of design rigor is going to happen in many industries around the world, right? In many different verticals.
And I think consumers, at least in sort of consumer products, are demanding that level of quality off everything. When I think when I was a child, you could buy something and it might not quite work and you might have to return it. But now it's kind of unthinkable if you buy an iPhone or something that it doesn't just work out of the box.
Yeah. That's absolutely true. So the demands of quality from consumers are much higher than they were before. And I think it's the demand of interactivity between even like big giant generators and the big industrial generators. Whereas before they'd be a black box and you turn it on and it works. Now the customers of these turbine and power generators, they're demanding access into how the internal workings of the machine is, right? How much power is it generating? Show me the actual curve. I want to control something. I want to turn it down at night, turn it up during the day, and so forth. So the manufacturers, it's not just quality, but they have to provide insight and interactivity. And the design issue now is much more important than ever it was before.
Mm-hmm. Yeah, so I mean, with all that change going on, what advice would you be giving people at early stage in a systems engineering career, or people who are perhaps considering to do a career in systems engineering?
Well, I don't. I think my advisor of undergraduate days are kind of behind me now, but I think engineering generally and systems engineering in particular, I think it's a great field to get into. It's a difficult field, but it's very important and continue to be important. So I would say, number one, I think it's a great career to go into. The world needs more systems engineers than they have now. There is going to be a shortage coming if it's not already here. And so, number one advice would be to do that. And number two, I would say especially for young people and recent graduates is to to really focus on what it is they're good at and take the work seriously. Like, I think it's not so important what you do, is how you do it, right? And really look towards honing a craft, right? So engineering, even though it's an engineering discipline, but there is still a craft to it. There's still a learning that goes into it. And if they have the mindset of a craftsman, that it's a skill that they just need to learn and hone, that will serve them well, as opposed to what title they have or what company they're working for. Oftentimes, learning from a small company could be better because you get much more access than you would, at a big company, for example.
Yes, and what I often advise people, the great thing about systems engineering, or engineering in general mainly, is that you could essentially any domain will need you, because as you mentioned, software is eating the world, and even if you wanted to run a hospital, like a systems engineering brain would probably help you run that hospital better. Like these skills can be applied to any problem.
That's I think really an excellent point that is not made often enough. What we're seeing now is people change careers much more often than they have. Right? I'm a perfect example of that. I went from being a prof to running a company. That's pretty much a 90-degree turn. And just because training as a systems engineer prepares you for more than being a systems engineer, right? It prepares you for a whole slew of tasks. It's kind of a way of thinking about the world, right? And analyzing problems. And that's going to be the key thing. And everything's become more complex. A systems engineering kind of approach, or an interaction kind of approach, is key.
Yes. And you mentioned about how in the future, where the generation of the artifact or the solution is potentially more automated, but being able to determine what is the intent, as you put it, or what is the what are the requirements, and all of this is needed in any industry, or even at governmental level. Like the more people who are thinking like this, I think the better chance we have in solving our big problems, globally.
That's right. Yeah, I totally agree in that, and we see that lack of, if you're trained to think in this kind of a design level thinking, let's call it, you kind of see these problems all over the place, and you can look at some of the solutions that get rolled out, and it's clear they haven't thought of it from a holistic point of view first, right? They thought if they could sequentially do all the components, then the whole system will work. And it's almost never the case given some sufficient complexity, right? That is the case. Right?
Yeah.
So something that maybe was done a bit more upfront analysis and upfront thinking would really produce a much better result much quicker. And then, there was a saying in astronomy that the best way to build a 10-meter telescope is to first build a 5-meter telescope and then build a 10-meter telescope, right? And that, you want to start small to figure out what all the problems are, and then go bigger, right? Another way to look at it is to think of what are all the pieces and how do they interact with each other, right? And which one should interact and which one shouldn't interact, and take care of that first before you worry about what each individual component does.
And so for your own career, how have you found the transition from that professor into the CEO role, where presumably you have quite different responsibilities?
I do, and I don't know how much of my experience is due to my training or due to my personality. So some kind of weird mixture of two. But there are actually some things that I find quite similar between doing fundamental research in quantum theory and running a company, strange as it may seem. The things that are similar is that you're never sure if what you're doing is the right thing, right? And you're always kind of worried that you missed something or you screwed up something can come and bite you. So you're always testing, you're always thinking, like, how can I make sure this is correct? What can I do and you're always kind of looking at this one area and say, okay, I'm going to fix this, and something else breaks and you run over there and try to fix that. That's kind of similar, I would say, for running a company and doing physics research. They're both complex systems, right? And oftentimes neither the inputs nor the outputs are the system itself is not well defined, right? And part of it is because you just don't know enough to define the system. Part of it is that the system itself may not be defined because there's a part of a creation there. You have to define the system that you're going to then diagnose and fill. So those parts are actually quite similar. The difference is, and there are significant differences as well, is that when in an academic career, especially in physics, I don't want to generalize because there is a lot of diversity in academic circles, but at least in physics, that is really the main thing is to get it right. There is a system, which is nature, that you're trying to figure out, and your goal is to try to get it right. Whereas when you're running a company, that's not possible, right? And even if it is possible, it's always a bad idea, right? So there is this idea that I've learned over the years running a company that sometimes, you always kind of want to make the right decision, but sometimes you have to make your decision right. A lot of it is very much more subjective. There is no final arbiter of it's always trade-offs, right? And so and you have to make a decision. You have to move forward, right? Even if you don't know what the answer is, then you pick one and just move forward and try to make it work. Right? So that's some of the differences, is the speed of decision making as opposed to in academia.
Yes, and I guess with clients, it's like if you're just improving the situation, even if you're not making it into the perfect situation, but improving the situation is in itself valuable.
Mm-hmm. It is, and in particular for a company like us, however, we have to be a lot better than the competition, because we not only have to win over our customers, we have to show them a solution. It's not only incrementally better than what they're doing now, because they have a switching cost as well. If it's a large organization, that they may say, okay, it may be better, but we're not willing to switch just for that. So we have to be a lot better. So you really have to re-envision the problem and really get to the root cause of the problems we're having and offer a solution that's very clearly far better than what they're doing now, right? Whether it be far better in terms of the technology the deployment, of the user experience, whatever vector you want to measure, it just needs to be much better.
Yeah, I wasn't appreciating that. If you are a smaller company, well, one, there is that switching penalty, but also, potentially it can be for that the manager or whoever makes the decision in the business, maybe they have to justify why they've hired a smaller outfit as opposed to a brand name that their boss is maybe more familiar with.
That's right. It's oftentimes safer. Status quo is always safer because it is a status quo after all, right?
So, given you've got these big plans for the next 10 years, I mean, are you hiring at your company?
We sure are, and hope your millions of viewers will go to QRAcorp.com/careers and have a look at what's available right now. We are hiring engineers, software engineers in particular, and so we are looking for them actively right now. We are looking for a product manager to round out our team, and that I would say those are critical hires for us right now as we're looking to expand. And always more salespeople. Right? Always looking to hire more salespeople, especially technical sales is they're not easy to find. Right?
And I guess ideally you'd like them to have a bit of experience either in a particular domain or in sort of selling software, engineering software to systems engineering clients.
Yeah, I would say all things being equal, we'd prefer to have more experience than less experience. The issue is not only are all things not equal, it's more like none of the things are equal. So in the end, we really want to get the right person, right? And the way I think of it now is if you think of, say, a junior engineer versus a senior engineer, there is a broad distribution of quality among junior engineers. There's a broad distribution of quality among senior engineers, and there's a big overlap between them, right? And so the important thing is to find the right person who has the right mindset. A growth mindset is important. Being able to work at a small company where it's not just, here are your tasks for the day and go to it. We require people with a lot of agency to help develop the company and go forward and really build something new. I think requirements engineering itself is a relatively new field, and so the market itself is developing as well as our product inside that market is developing. So we need people who can think at these different levels.
That's great. And I mean, how have you found the pandemic? I don't know what the situation is in Canada right now. This is June 2021, but have you been able to almost be business as usual, given your work is maybe on computers?
It's definitely not business as usual because the world is not as usual. But I would say we have adapted better than maybe other companies were because we're a software company and we are physically capable of working remotely. Whereas if you're actually building something, you have to be in a lab, and if you're on a restaurant, it's even worse. Right? So in that sense, we do better than both. If you look at what is the impact of COVID generally and the rise of remote work. Right? So a move to remote is obviously the biggest surface change that's happened because of COVID. The way I view it now, and it's a view that's evolving over time, is really what COVID has accelerated existing trends by 5 to 10 years. Right? There already was a trend towards remote. We've sort of leapfrog over it. Right? We know now, we may have suspected before, but now we know that the core technology, video conferencing, broadband internet, Wi-Fi everywhere, cell signal stability, what else, cloud storage and sharing, the core tech is good enough today, and it's rapidly getting better. So many companies are able to work remotely. There's probably needs some work on processes. They do need to get a little bit better. We're all still learning. Productivity, I think, appears not to be as bad as people were originally worried about. But things like the cadence of meetings and how to handle, if you're remote, things tend to be a bit more asynchronous, or they ought to be more asynchronous. And so how do you handle that as a company that was used to being people co-located? That's something that has to change and be and adapted, right? But it's pretty clear remote is here to stay. Maybe not 100%, but we're certainly not going to go back to the way things were ever. Us as a company, but also us as the world. I don't think.
Yeah. I mean, I'm hoping for a bit of a hybrid model. I think that there are benefits to both sides, and I don't know, a year and a half now of not having a physical meeting. Like I'd like to have a workshop or something in person. But
yeah, I think that's a good point. And so some things are better, some things are worse, right? And it's just a different thing. So overall, it's not better or worse. It's just different, right? So I think one thing that is better, at least for me and many other people, is there's a big reduction in travel. Right? So if you had a big company meeting with departments that were spread across the country or the world, to have a big team meeting, you have to fly there to co-locate. So a 3 or 4 hour meeting plus lunch, dinner, breaks, travel, hotels, a 3 hour meeting could take like 2 or even sometimes 3 days to complete. Right? Now with Zoom and Google Meet, a 2 or 3 hour meeting takes 2 or 3 hours to complete, right? So the meeting quality is almost certainly less than it was before. There's no question about that. But there's a huge savings of time that savings of time, counteracts the degradation of quality of the meeting, which is actually improving, right? Things that I think are bad are things like team morale, culture and loyalty, and mental health issues, especially because you're hidden now. If you're just see each other on a video interface, the social clues to get other to help you may not be there. And so that's an issue that needs to be resolved, I think.
Yeah, I think as well for sort of junior staff, or if you've got, an established family and, a big house and home office, work from home can be, quite comfortable, and you get to see the children more. But I have heard I've known of people who've their first job out of university has been remote, and they get a laptop sent to them in the post, and it's like, start your new job. And it's that, I mean, aside from all the children and their sort of education issues from in school during the pandemic, I'm not sure if starting a job like that is ideal.
Yeah, that is I think a big issue. This feeling of belonging and togetherness in teams are very important. I would say, in engineering, the teams that bond together and know each other and have been together for a long time become better as a team just because they've been together a long time, and there's a compounding effect. And when you're remote and you join a team remotely, that's just much harder to do, right? So those are definitely some of the negative things that we need to still find some way to counteract that.
And I think also a good team, it needs to have sort of failed together and gone through hardship together and sort of helped each other through that. And whether that's possible to replicate, at least with our existing electronic tools, I don't know. So, well, it's been fascinating, Jordan. I mean, do you have anything else you'd like to add to tell the listeners?
No, I think we covered a lot of ground. I appreciate it. It was fun talking about this stuff. Yeah.
Thank you, Jordan.
Very, very enjoyable.
So if people want to know more about your company, QRA, what should they do? Or if they want to get in contact with yourself?
So our web address is QRAcorp.com. And that you'll learn everything about the company. If you want to contact me directly, you can just email me at jordan@QRAcorp.com. You can also find me on LinkedIn, on Medium, and all over the interwebs.
Great. And if you like the sound of the company, be sure to check out the website and the careers pages if you like the idea of working with QRA.
Yes, please.
Or buy the software and get it implemented in your company. So thank you.
Even better.
So thank you, Jordan. It's been excellent, and look forward to seeing you soon. Hopefully in the real world, if I can get over
Thank
to
you,
Canada.
Joshua. Or me in the UK.
Yeah. Great. Thank you.
Okay. Take care, Joshua.